Degree of saturation can be understood as how much empty space present in the soil sample is filled with water. If this space, which is called pores, is completely filled with water, then soil is called fully saturated. If no water is present in this space, then soil is called dry. And if this empty space is partly filled, then soil sample is called partially saturated soil sample. Now this diagram represents partially saturated soil, and this diagram also represents partially saturated soil, and this one too. So there is clearly a need to define the term degree of saturation to differentiate between these states of soil and to know how much partially saturated soil is saturated. So let us define the term degree of saturation, which is denoted by capital letter S. Let us consider the three-phase diagram of a partially saturated soil. Degree of saturation for this soil sample is defined as volume of water to the volume of voids this soil sample contains. Degree of saturation sometimes represented as percentage and sometimes doesn't. It can be written as this in the equation form. Since the degree of saturation indicates the portion of volume of voids which is filled with water, so when soil doesn't have any water in it, then value of VW in the equation becomes 0, and hence the degree of saturation comes as 0. And similarly, when all the pores are filled with water, then volume of voids is equal to the volume of water present in the soil. So in the equation, value of this ratio becomes 1 and degree of saturation comes 100%, or simply 1 if not shown as percentage. Volume of water VW can never be greater than volume of voids VV in a soil sample because water stays into the voids. But VW can be equal to VV when pores are completely filled. Hence, value of degree of saturation will never be greater than 100% but may be equal to it. So the value of degree of saturation for soil will always be between 0 and 100 if we show it as a percentage.